Everything looked normal, but something in the system was already broken. No alerts, no spikes, and no alarms. Just silence across services that were supposed to be healthy. Website didn't crash, they stopped resolving. APIs didn't fail, they disappeared. Apps didn't break, they became unreachable. And the strange part, every dashboard said the same thing. Green, healthy, operational. So the question wasn't what failed. It was, how can everything look fine when nothing works? The answer wasn't in the application layer. It was deeper, and the system that decides where everything exists, DNS. And it wasn't loud when it failed. It was silent. DNS is the Internet naming system. When you type a domain like google.com or youtube.com, your system doesn't understand the name. It needs an IP address. So the DNS translates name to address. This happens billions of times per second. It is designed to be invisible, fast, cached, and distributed. But that design comes with a trade-off. DNS is not one system. It is many systems agreeing on a temporary version of reality. And when that agreement breaks, you don't get a clean error. You get inconsistencies. It starts with a routine change, a DNS record update, small, controlled, and standard procedure. The kind of change engineers deploy every day. At first, nothing breaks, which is expected, because DNS does not update instantly across the internet. It propagates across ISP caches, recursive resolvers, and local device caches. Each layer storing its own temporary truth. That's normal system behavior. Until we introduce one critical variable, time to live. Time to live defines how long a DNS record is considered valid. And that means something important. The internet is always slightly out of sync. So when a change happens, some systems say the new version. Others still say the old one. And both believe they are correct. Now the system stops behaving as a single system. It fragments. Some users connect instantly. Some fail immediately. Some never resolve at all. Same domain, same infrastructure, different outcomes. This is where the failure becomes dangerous. Because there is no full outage, only inconsistency. And most monitoring systems are not designed for inconsistency. They look for traffic drops, error spikes, and latency increases. But DNS fragmentation produces something different. Partial failure without clear signals. Some dashboards remain stable, while users experience collapses. Engineers checked the system. Everything looks normal. No alerts, no abnormalities, and no obvious errors. So the default conclusion appears: if nothing is triggering alarms, nothing is wrong. But something is missing. Not failed servers, not crashed services, but missing responses. Lookups that never return. Queries that time out silently. And requests that disappear without logs. And that is the hardest type of failure. One that produces no signal, because you cannot diagnose what you cannot observe. So the system does what it's designed to do. It ignores the absence, and silence gets interpreted as stability. One engineer stopped trusting the dashboards. They go deeper. Not metrics, not summaries, but raw DNS logs. And the pattern becomes visible. Failed lookups increasing, regional inconsistencies, cache mismatch across resolvers, NX domain responses appearing where valid record should exist. This is not random failure. It is structured fragmentation. Parts of the system are broken, but no single component has failed completely, which is why automation missed it. Because automation dictates collapse, not split reality states. Once understood, the fix is straightforward. Roll back the DNS change, flush caches, and allow time to live cycles to expire. Then wait. Because DNS does not recover instantly. It recovers through time. Gradually, cached incorrect states expire. Resolvers refresh. New records propagate. And the system begins to converge again. Not instantly, but layer by layer, until all systems finally agree on one version of reality. This was never just a DNS failure. It was a visibility failure. Modem systems are powerful, but they can only reflect what they are designed to observe. And not all failures produce signals. Some look like delays. Some look like noise. Some look like nothing at all. DNS failures exist exactly in that space, between system state and system visibility. And that gap is where real risks exist, not in the code, but in what the system cannot see. One DNS change, one propagation delay, one fragmented cache system, and a system that never fully failed, but never fully worked either. Dashboard stayed green, automation stayed silent, but reality drifted underneath. And only when someone looked deeper did the system return to alignment. Because the most dangerous failures aren't the ones that crash. They are the ones that quietly split reality without ever showing it. If you want to see more real-world systems like this, broken down in a clear engineering first way. Subscribe, because the next failure isn't going to announce itself either. Thanks for watching, and I would see you in the next.